All right, in this video, we're going to continue talking about the double angle identities. This time, we're going to look at the double angle of cosine. As you can see, there's quite a few different identities for the double angle of cosine. Me personally, I have just always used this one. It's not to say that it's easier. It's not to say that it's any better, because they're all the same. They all have different ways of being used, specifically just depending upon the problem. Maybe we're simplifying an expression and we wind up with one of these, and then we could rename it as the double angle of cosine. There's no better way to do it. Just again, personally, this was just always the one that I had memorized, I had gone through. But in the following examples, any of these examples and formulas will work. So I highly recommend that you try using all three in the examples below. You'll find whichever one you can memorize the easiest and go from there. So let's just jump straight into the examples utilizing our double angle of cosine. So given that we have sine of theta being -5/13, and we are in quadrant 3, let's go ahead and draw our triangle. So we're going to look very similar to this. And I know that sine is opposite over hypotenuse. And then we need to find our adjacent side. So we have -5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. B squared equals 144. And b equals 12. So boom, we have all three sides of our triangles. Now we can finally utilize our properties and identities to find the double angle of cosine. So what I want to do is I want to take my double angle cosine formula. And again, I use this one. You can use whatever you want as long as it's double angle of cosine, and go from there. So I have cosine squared, which is going to be 12/13 squared, minus sine squared, which is going to be -5/13 squared. And we're going to simplify this out. So what I'm looking at doing is just squaring each term. Remember, that squared term goes to the top and bottom. So I have 144/169 minus, well, 25 squared is going to be positive. But we have squaring it, so it's going to give us a positive there. So I have 25/169. Now, I just caught something, and this is it's good to go back and make sure we've done this. I want you to look right here at my value of cosine. Cosine is on the negative values of x, so we actually need to make sure that we're calling that -12. Even though we didn't get that here, we know that based on our all students take calculus, in quadrant 3, sine and cosine are negative. So I need to make sure that I keep that negative and make that change right here as well. It's not going to affect our answer because we're squaring it, but we still want to be good math students and make sure that we have everything correct. So my apologies on that one. Got ahead of myself. 144 minus 25 is going to give us, 119/169. And that's it. That is our double angle for cosine when looking at that given information. So hopefully pretty straightforward. Again, make sure you are keeping signs correct when we are looking at these problems and not making the same mistake that I just did. So let's look at another example here. Give ourselves a little bit more room. Find the double angle of cosine when the sine of theta equals 3/4, and we are in quadrant 1. So we'll draw a triangle in quadrant 1. They give us that sine is opposite over hypotenuse. We need to find our missing side utilizing the Pythagorean theorem. So that's a very simple process for us to do. And we get that adjacent side is the square root of 7. So now utilizing our double angle identity here to find the double angle of cosine, we have cosine squared theta minus sine squared of theta. And I'm just going to plug in everything that I have. So I have root 7 over 4 squared minus 3 over 4 squared. And we're going to simplify this out. I'm going to give us a little bit more room again. Now let's do this. And so now, when I distribute in that power of 2, that's going to give us 7 over 16, because again, it goes to the top and bottom, minus 9 over 16, which is going to wind up giving us negative 2 over 16, which simplifies to negative 1/8. And that is our double angle of cosine. So I'm really happy you guys checked out the video. I hope this makes sense. Again, watch those negatives. Make sure that you are utilizing any of the 3 double angle cosine formulas. They'll all work out for you. Thanks for checking out the video. We'll see you next time.